Hello guys, welcome back. Today in this video we'll be discussing about likelihood ratio tests. Before starting, we should first address the question that why will we waste our time to learn this concept, this new concept? Why is this concept, likelihood ratio test, at all important? As you know, that in certain statistical setting, UMP test, considered with the best test, may not exist. For example, if you take x1, x2, xn follows normal mu comma 1, you want to test mu is equal to 0 versus mu not equal to 0. In this double-sided hypothesis, alternate hypothesis, the UMP test does not exist. So the question is that how do we find a reasonably good and intuitive testing scenario? The likelihood ratio test is one of such solutions to this problem. We'll explore in the next part of the video that what is the likelihood ratio test, and we'll give one example to help you learn that. Thank you guys. I will see you in the next part of the video. Stay tuned. Bye bye. So, hello guys, let's start discussing about the likelihood ratio test. So, the likelihood ratio test is an extension of the Neyman-Pearson lemma. The Neyman-Pearson lemma says that if there are two hypotheses, simple hypothesis, H naught, let's say X belongs to F naught versus H1, X belongs to a different distribution, then the likelihood of an X belonging to F naught divided by the likelihood of X belonging to F1, they should be lesser than some quantity if, I mean, should imply that H naught should be rejected. That means F1 is preferred more than F naught. So we are kind of extending this idea to a likelihood ratio test. The idea, because UMP test does not exist in certain scenarios, as we have told in the previous part. So what we'll do is that we'll define a quantity that is similar to this quantity. We call it likelihood. We can call it this, a quantity, where what we will do? We will first let me define the statistical hypothesis. H naught is that theta belongs to some theta naught versus H1 is that theta belongs to some theta 1, and theta is nothing but theta naught union theta 1. Of course, this intersection, this is equal to phi, that they are disjoint. Okay, that is joint. Oops. So what we'll do is that we'll do something interesting. We'll define the likelihood. Now the data follows certain, of course the data x1, x2, xn follows certain distribution with the parameter theta.
Okay, so what we'll do is that we'll define this quantity, which is saying that likelihood of theta naught. In some sense, it's saying that it's the theta naught hat. It means the maximum. So this is almost like maximum estimation. So it's finding out that what is the best possible approximation to theta, that is this, and corresponding to that, what is, so first finding this means what? This means first finding the best approximation to theta in the corresponding parameter space, and then finding the likelihood value of that. So it's finding the most probable likelihood value, you can say. It's finding the most probable theta value and hence the most probable likelihood value in that set of the null hypothesis, divided by the likelihood of the entire region. The likelihood hat, that means max theta belongs to theta. So this is the overall, and this is the only null hypothesis. Okay. Now understand, of course, this is less than equal to 1, of course, because this is maximum more. This is an exercise, just verify this. And greater than equal to 0 because it's a probability function of probability, like probability by probability. So now, when will we reject? When will we reject H naught? We reject H naught if this quantity is very small, is less than equal to certain quantity. Small. Why? Because if it's small, that means the maximum, if the maximum is within this theta naught, then the max, if they're like, if theta is actually between theta naught, okay, then the likelihood, the probable likelihood, if theta is actually between theta naught, understand, then the theta, the maximum of the likelihood, the probable likelihood will be maximum will occurring here, and the maximum of the probable likelihood of the entire space, since theta is within theta 1, will be occurring at the same point since theta is between theta 1. Therefore, this two will be equal, and hence it will be closer to 1. But if it's less than, that means what? That means the maximum is not inside theta naught, but outside theta naught, since in theta 1. So therefore, we reject H naught if this quantity is less than certain k. So this is a rejection region. It's a set of all x such that this is a function of a sample, right? The data set sample. This is a rejection region, right? So let's try to apply this, and now we can find the best test, but using all this alpha and this thing. But what we'll do is that we cannot find the best test for the UMP test for the scenario. I give an example, right? That x1, x2, xn follows normal mu comma 1. You want to test h naught, mu is equal to 0 versus h1, mu not equal to 0. How do we test this? Simple. Use this thing. So check that. So let's set up theta naught is equal to 0 here, and theta naught is equal to minus infinity to like 1 to 0 union 0 to infinity. Everything except theta naught. against 0, I'm sorry, and focus on, let's say, the variance, of course, it's 1. So you can also do the same for non-variance, but let me show you for non-variance. Therefore, L of mu, you know that it's nothing but 1 by root 2 pi into 1 for sigma whole to the power into exponential minus summation of 1 to n xi minus mu whole square by 2 into sigma square, but sigma square is equal to 1. So you know that, and yeah, so also this is nothing but the whole real number line, the whole space. Therefore, this quantity L theta naught hat by L theta hat is equal to maximum theta. Now, if since it's theta, so there's only one quantity, the maximum will happen at that quantity only. Okay, and maximum theta not equal to 0. Like theta is equal to, here you can consider as mu. This is theta. Let me write that in that format. So max mu equal to 0, L mu by max mu not equal to 0, L mu. Sorry, mu max mu belongs to real number line because it's over. Yeah. Remember, it's not over theta 1, but all theta not union theta 1, the whole possible space. So this one is nothing but mu is equal to 0. You just put the value. It's 1 by root 2 pi whole to the power n into exponential minus summation I from 1 to n xi square by 2, since mu is equal to 0. Because at that point only it's a maximum. And for the x mu is equal to real number part, that's where this is the value of the MLE, right? The MLE of mu, and we put that MLE into the likelihood. It's nothing but L of mu MLE. So you put the value of the likelihood, and that's what it happens. And you know the L of what is L of mu MLE? You know the L of mu MLE, 1 by root 2 pi whole to the power n. We'll cancel out exponential minus, you know what is a MLE? It's x bar, right? Mu MLE whole square by 2. So this is the quantity, the special quantity. And this must be less than certain k to be rejected. So you will find that k from the level of significance alpha and all those things. But the goal is to find the rejection region, the form of the rejection region. So this gets cancelled, and we get that exponential. This goes above half times summation I from 1 to n xi minus x bar whole square minus xi square. It must be less than equal to k, which is equivalent to saying that, so you can just take log on both sides and 2 multiplied on both sides. So it's summation, since they are increasing function. So you can just, what I will do is that I will make my work easier. I will just, this is the usefulness of mac. It's less than equal to certain k dash. K dash is nothing but twice of log k. Okay, so this is nothing but summation 1 to n. Xi square gets cancelled. So you get two things. Minus 2 xi x bar and plus x bar square less than equal to k. And finally you get, if you add it up, you get what? You get minus 2 common, x bar common, and it's summation x. Summation x is nothing but nx bar. It's, you get nothing but minus 2n x bar whole square plus x bar whole square is less than equal to k. And therefore you get that x bar whole square into 2n minus 1 is greater than equal to k dash. So of course n is greater than equal to 1. So this must be, there is at least one sample. So it's same as saying that x bar square is greater than equal to certain k double dash. This is the form of the, that means x bar is greater than equal to certain k1 and x bar is less than equal to certain k2, or x bar is greater than equal to k1 and x bar is less than equal to minus k1. So yeah, imagine this is a square, it's greater than equal to certain, so it's like either on this side or on this side, because the value need to lie on this upper portion, and it's k minus k1 and this is k1. So this is a rejection region. It makes sense because if it's further on both sides, then it'll reject the thing. And this is the entire idea. And it is a logical way of thinking. So therefore, likelihood ratio tests are nothing but is an extension of the intuitive idea of Newman-Pearson lemma. So it's like kind of creating a pseudo powerful scenario by using this corresponding methodology. I hope you understood that, and this enhances your perception. So understand, since it makes sense that if there's data, if the data is on, this is the mean. So if the mean of the whole data here is coming on this side, on the both the tail, that means most probably the actual theta mu is not equal to 0 because the mean is lying far away from the 0. So that's the basic idea. On both sides it should occur, not on one side. So that's the basic idea, okay? So I hope you enjoyed this. If you enjoyed this, do share with your friends, do subscribe, like, and yeah, thank you for watching this till the end of this video, and I will see you in the next video. Stay tuned and stay blessed.